All right, welcome back, the genius. So in this session, let's talk about the division, the modulus, and the exponential operators. So this is basically the last operators, the last arithmetic operators we'll be talking about. Okay. So the division operator is used to perform division between two numbers. But the thing is this, when it comes to division operator in Python, it behaves somehow. So we are going to understand how it behaves. So the normal way you do 2 divided by 1 or 10 divided by 5, okay, there's a little difference when it comes to Python. So we have what we call floating point division and we have what we call integer division. Okay, so when you use just when you use just this symbol, when you use this forward slash, Python performs floating point division. So whatever you do with this, Python will return you a floating point. So it will always return a float, even if the numbers divide evenly. Okay. Now look at this example. 10 divided by 2 is supposed to give us just 5. But any division you do with this normal division, Python will return a float. Okay. So let's go to our website and to our editor. If I say, if I do something like print, I say 10 divided by 2. If I run this code, I'm going to get 5.0. So this is called the floating point division. But in normal programming languages, the other programming languages, it will just give you the integers. Okay. But now for Python, it will give you a float. It will return a float. So this is what we call for the floating point division. Okay. If you print 7 divided by 3, okay, something like that, it's going to give you a very long precision. If you say 7 divided by 2, okay, is going to give you, or maybe 7 divided by 3, is going to give you a very long precision, okay? So when you're working with division in Python, you have to be very, very careful. In short, before you even do anything, you should be checking what your result is coming, what you're getting as a result. Okay, we might not be discussing the reasons why all these things happen here. We might discuss them in Python mastery. Okay, but for now, just understand that when you're doing this kind of division, there are going to be sometimes unexpected results. But when you're doing the normal division with Python, it is the floating point division. Okay, so there's another one we call the integer division. Okay, so if you want to get an integer out of this, you're going to use the floor division, or we also call it the integer division. We call it the floor division or the integer division. So if you want to perform integer division, you use the floor division. So and just one forward slash is floating point division. Double, two of it is integer division or floor division. Okay. So it will round the result down. Okay, it will round it down towards the smaller integer. So when you have 10 floor division by 3, it is normally supposed to give you 3.333 or something like that, but it's going to just give you 3. It will round it down. It will round it down to the nearest whole number. All right. So if you just want to get the integer division, okay, you use the double forward slash. But if you want to get it as a float, you use the normal, just the one forward slash. If you want to get the integer, all right, you do the double forward slash. So if you do something like minus 10 divided by 3, it's going to give you minus 4. So this is somehow crazy. Minus 10 divided by 3. Okay, minus 10 divided by 3 is giving you minus 4. So 10 divided by 3 is supposed to give you 3. But if you're doing the minus 10 divided by 3, it's going to give you minus 4. It's just so crazy. Okay, it's just so crazy how Python does this. So if you say minus 10 divided by 3, it's going to give you minus 4. minus 10 divided by, oh, sorry, I was using the normal, the floating point division. If you say minus 4 divided, floor divided by 3 or integer division, it's going to give you minus 4. So we might not be explaining the reason why all these things are happening here because it might be too much for us to understand. But just be careful when you're working with this. Okay, just be very, very careful when you're working with this. So, but when we start dealing with Python mastery, we'll be talking about then you would have gotten enough knowledge to understand what is happening behind the scene. But just be very careful. Okay, when you do 10 floor division or integer division by 3, it will give you 3 because 10 divided by 3 will give you 3 remainder 1. But if you're doing minus 10, okay, it will just give you weird results. It will give you minus 4. If you're doing minus 10, 10 divided by minus 3, look at what it's going to give you. It's going to also give you minus 4. Okay, so it's just weird. Okay, just be careful when you're working with division, especially in Python. Okay, so division with different number types. If you try to do I showed you this thing in the previous one where if you multiply anything with a a floating point number, or a float, sorry, it will convert everything to float. So Python will automatically convert the operands to float if at least one of them is a float. So when you say 10 divided by 4, all right, there's no conversion there. Both of them are all integers. But when you try to do 10 divided by 2.0, it will convert this whole thing to float division. Okay, because you're saying one of them is a float, so it will automatically convert it to automatically convert both of them to floats. Okay, so if you say 10.0 divided by 2, it would also convert the every other thing from integer to float, because at least if one of them is a float, it will convert all the operands to floats. Okay, so you cannot divide by 0. If you try to divide by 0, you get an error. Whether you're doing whether you're doing integer division, whether you're doing the floating point division, if you try to divide by 0, you're going to get an error. So you cannot do this. You cannot divide by 0. In anything at all, you can never divide by 0. So it's going to throw an error. So how do you handle this? There's something we call try except. Okay, this is how you handle error. So when we talk about error handling, we'll now talk about how to handle this error. Okay, but it will definitely throw an error. So, but there is a concept called try except. Okay, it would actually we call error handling. Okay, so when you have anything that could cause error, you can handle it yourself. So when we talk about error handling, we are going to explain what is happening. But for now, just know that you cannot do division by 0. It will throw an error. Okay, let me show you something. Let's go and try to divide by 0. If I say 10 divided by 0 and try to run this, it will give us an error. Okay, we have an error. Look at the output. Even if I try to do the floor division, let's see what it will give us an error. The same thing. You can never divide by 0. You can't divide by 0. Okay, there's another method Python provides. It is called the div mode method. With this div mode method, all right, it is a function that returns a tuple. And in this tuple, you get the quotient and the remainder. So let's say we try to divide 10 by 3. So if you want to use the div mode, this is how you use it. So if I go on, I want to do a division, and in that division, I want to get both the quotient. The quotient is actually the the quotient is actually, if you say 10 divided by 3, 3, the answer will be 3, which is the quotient. Then the remainder will be 1. So, but this div mode, all right, it will take two parameters. It will take the numerator, let's say 10, and the denominator, let's say 3. When you try to do this, okay, you will get a tuple. So we say print result. This result is going to be a tuple containing the quotient and the and the remainder. Okay. So this is a combination of division and modulus. We'll still talk about modulus. So if you want to get if you want to get the quotient and the modulus in one go, you can use the div mode. So there's something we call unpacking. So I can just say quotient, all right? I can say quotient and then remainder is equal to rest. And if I print quotient, I print remainder. Let's see what we get. We are going to get 3 and 1. Okay, so this is called unpacking. I mentioned it in a previous session, but don't worry, when we start talking about tuples, we'll talk about unpacking. Okay, so I was able, because I know that this is going to return a tuple, all right, this function is going to return a tuple, and in that tuple, it will contain the quotient and the remainder. So if you look at it, 10 divided by 3 will give you 3, so that's the quotient. And 10 divided by 3, the remainder will be 1. So if you want to get the quotient and the remainder in one straw object, you use the div mode. Okay. So just so you know, there's a function like that. So let's talk about the modulus. The modulus in Python, or in short, in every programming languages, would return the remainder of a division. So when you say 10 divided by 3, the modulus is 1, the remainder is 1. So this is the syntax. A modulus. So you use the percentage sign to do it. So let's say if I say print, I want the remainder of 10 modulus 3. So it is the percentage symbol that you use for the modulus operator. When you print this thing, you're going to get the remainder, which is 1. So 10 divided by 3 will give you 1 as the remainder. Okay. So if A is divisible by B, the result will be 0. So if you say 10 divided by 2, there is no remainder. So the remainder, of course, is 0. Of course, there is a remainder. So, but the remainder is 0. So if you say 10 divided by 2, there is no remainder, but the remainder will be 0. Okay, so you say 10 divided by 3 to give you 1, that's the remainder. 10 divided by 15 divided by 5 will give you 3 remainder 0. So the remainder will be 0. That means that's what you will get. Okay, if you say 7 divided by 4, the remainder is 3 because 7 divided by 4 will give you 1 remainder 3. So this is how the modulus operator works. So there is a trick you can use we can use the modulus operator to do. So if you want to find the last digit of a number, all you have to do is to divide that number by 10, by modulus 10. So let's say you have a number like this, 1, 2, 3, 4, 5. If you want to find out the last digit, all you have to do is to do the number modulus 10. So let's say I have a number like this, and I was asked to find the last. I have this number, 8997, and I was asked to find the last digit. So the last digit could be, I was saying num modulus 10. So it will divide this whole thing by 10, and the remainder would be the last digit. So we are expecting that the last digit here is 7. So when we run this thing, we are going to get 7. So this is how you find the last digit of any number at all. Because the thing is that 10 number divided by 10, it will divide to give you 899. Okay, that's what it will give you, and the remainder is 7. Okay, so that is a trick you can use the modulus operator to do. So to find the last digit of a number, you can use the modulus operator to find it. Just divide that number by modulus 10. Okay, so exponential operator is like the way we do 2 raised to power 3. If you want to get 2 raised to power 3, okay, we use, this is what the exponential operator does for you. It is used to raise a number to a power. Okay, the basic operator is just used to calculate powers of numbers. So instead of using 1 star, you use double star. So the base, double star the exponent. The base, double star the exponent. So if you set 2 exponential 3, it will give you 8. It will do 2 raised to power 3. Okay, so let's go to code and see. if I want to get the power of 2 raised to power 3, I will say 2, okay, 3. And if I run it, I'm going to get 8. All right, so this is the power. This is how you raise a number to a power. So it's the exponential operator. So if you want to do 5 raised to power 2, that will give you 25. That means you do 5 star, double star 2. Okay. So, but if you say 10 raised to power 0, it will give you 1. Okay. Any number that's raised to power 0 is 1. You already know this from mathematics. Any power raised to, if I say 2 raised to power 0, it will give me what? 1. All right. So you can also do exponential with negative numbers. A negative exponential means the reciprocal. All right, the reciprocal. So if you say 2 exponential minus 3, it's going to give you the reciprocal it will give you 1 divided by 2 raised to power 3. Okay, so it's going to give you the reciprocal. Anyway, all these things are coming from mathematics. I believe you know them. Okay, so when you say 2 raised to power minus 3. It's going to be 2, it's going to be, let me give it's going to be 1, it's going to be 1 over 2 raised to power 3. So if we run this thing now, we are going to get the reciprocal. Okay, we are going to get the reciprocal. So just be careful with this. Okay, if you also do 5 exponential minus 2, it will be 1 raised to power 25. Okay, that is what you're going to get. So you can also do with fractions. So with these fractions, you can actually get the roots. So if you want to calculate reciprocal, you use the exponential will not be minus. If you want to get the roots, okay, you will use fractional exponent. So you can say 9 exponential 0.5 is going to give you the root, the square root of 9. If you want to do 27 exponential, okay, now look at it. This will give you this cube root. Okay, so let's say you want to get the square root of 9. All right, instead of doing exponential, let's say we have here, we want to do square root of 9. Okay, what you're going to do here is you use a fraction 1 over 5. Am I correct? 1 over 5. Sorry, 1 over 2, not 1 over 5. I'm sorry. It's 1 over 2, not 1 over 5. Okay? 0.5 is what? 1 over 2. Am I 10 over 0.5 is what is wrong with me? 0.5 is what? 5 over 10, which is 1 over 2. Okay? So it's supposed to give us, sorry. Okay, sorry. You see, I was having an issue here. See, I was supposed to do it this way. You see that precedence we are talking about. What it was doing for us, it was, without this bracket, it was doing 9 exponential 1, then divided by 2. You see, but if I do this now, we'll get the correct answer. So you can see, first of all, if you have anything, I make sure that it is in square bracket like this. If you want to do the cube root, if you want to do square root, the exponential will be 0.5, or you put 1 over 2 in parentheses like this. If you want to do cube root of a number, let's say cube root of 27 is 3, we are going to do 27 exponential, sorry, we're going to 27 exponential 1 over 3. And if we run this, we will get 3, 2. So this is the cube root. This is how to get the cube root of a number. All right. And this is how to get the square root of a number. Okay. You can always practice with this. Always practice with this. We also have another number called the power function. The power function, instead of using the raw exponential, you can just use the power function like this. Use the power function, then you give it the base and the exponent. Okay. So if I want, instead of me doing this thing this way, I could just say power okay, and I will say 2, which is the base, then exponential 3. The exponent will be 3. So if I do 2 raised to power 2, so I'm going to get, sorry, I didn't print it out. Sorry about that. If I print it, okay, it's going to give me 8. So the first argument is the base, and the second one is the exponent. So even if I say, if I do, the first one is 9, and the second one is 1 over 2, it will give me the square root. Look at it. It will give me the square root. Okay, so if I want the cube root, I will just do the same thing where I did. Just make sure that the exponent is exactly how you want it. So if I say the cube root, I will now do 27 over 3, and I will get the cube root, which is also going to be 3. Okay, so but there's another. So if I say 2 and I do 3 and I give another 1. Okay, if I put another, this thing takes up to 3 parameters. If I put another number here, like say, like 3, what this is going to do is that it's going to do 2 exponential 3 modulus 3. Look at it. 2 raised to power 3 will give us 8. 8 modulus 3 will now give us what? 8 divided by 3 will give us 2 remainder 2. So if I run this thing now, we are going to get 2. All right. So if you do not, this power method, this power function, if you call it like this, it's just going to give you the exponential or the power of the base. All right. So the base here is 2 and the exponent is 3. So it will give us 2 raised to power 3. But if you provide another argument here, all right, it's going to now do 2 raised to power 3, which will give us 8, then 8 modulus 3. So this is what is going to, let me put a comment here. This is going to do 2 raised to power 3, all right, like this, okay, then modulus 3, okay. You see the first one, 2 is the base, the first 3 is the exponent, and the next 3 is the modulus we are doing with. So if I run this now, we are going to get 2 raised to power 3, which is 8, modulus 2. That will give us 2. Modulus 3 will give us 2, okay? All right, just play with it. Okay, so you can also raise power by negative, okay? So just try it out and see. So thank you very much, okay? We have just concluded all the arithmetic operators that you find in Python. If you find anything confusing, you don't understand anything, please always reach out to us. Our WhatsApp number is always available. Always reach out to us, okay? Thank you very much. Do your assignment, do your test, and we'll see you in the next session.